Welcome, everyone. During our webinar on April 2026, when AI agents get the key to your network, we covered a lot of concepts, starting from identity through MCP tool access level, and also we covered problems with insecure tools and the necessity for device level security, and also attribute-based access control. At the end, we also dealing with the concept of end-to-end auditing. Because of the vast number of concepts and problems, we didn't able to dive deeply into some configuration details and implementation details because of the limited time of webinar. Therefore, we decided to split those concepts into three-part series. And today it is the part number 2 about insecure MCP tool and device level security. And of course, in the part 3, we will cover attribute-based access control and end-to-end auditing. So I highly encourage you to see all the parts. My name is Tomasz Janaszka, and I am solution architect at CodiLime, dealing with the projects applying AI and machine learning techniques into various challenges concerning the network and IT infrastructure management. Let me recall the problem that we were trying to solve, and particularly focusing on what we would like to cover in this part. So the problem is that we have the users with different roles that would like to interact with our network via various applications that are using agents and MCP servers, exposing various tools able to retrieve information from network devices and also performing some actions on them. So the problem is with the accountability. We would like to assure that those agents need to utilize only the permissions of particular user, and depending on the roles and permissions of the users. So agents also must access only those devices that are authorized for particular users. And of course, we need to assure end-to-end audit trace what performed, what actions on our infrastructure. But in this part, we will still focusing on our first objective, assuring that the agents are not acting outside the permissions of the particular user roles. So comparing to our first part, when we're dealing with the enforcing some and filling the gaps that we between AI agents and MCP server, today we will focus on the communication between the MCP servers and the network devices, especially executing particular tools. So we will cover the proper credential handling, and also we demonstrate that there is a need for a device at command control and also some authorization on command at the network device level. So we would like to mention about the antipattern, because it may happen that we could just provide an insecure MCP tool, and this is the example of such a tool. So let's look that this is the run row command on device. We provide the device and the command, very simple, but we mark this required scope as MCP control plane read, making this tool effectively for all the users. And the second problem with the tool that here, of course, it is very simplistic form of the tool. This is the connection to the device using the SSH and execution of the command. The problem that here we could inject any command. If this command is not properly validated in the code, effectively we are giving the access to all the commands on our network devices. That could be very detrimental. So this is the problem. There may be different reasons. For instance, one of our developers just used this tool for some testing purposes, or the MCP server can be delivered by the another vendor, and a bug is existing. This example is very clear, but in many cases it may take a very subtle form, and usually it is related to not proper validation of the inputs that we are passing to the tool commands. In the demo, we would like to demonstrate how this tool can be used using the properly prepared prompt injection and forcing our agents thus to use this tool that we discovered. Especially this is the case for the attacker. If it discovered, it could utilize these tools, crafting proper prompt to our agents. We would like to demonstrate that such situations may happen. Therefore, there is a need for device level enforcement. But first, demonstrate what could be done if we have such a tool. Continuing our video, we are logged in our application as Alice. And here we prepared the switch enabling this row command tool. So here we could easily see that the agent for Alice has the right to use this particular insecure tool. And now we could easily prepare the prompt, for instance, remembering that the Alice is not allowed to use prop tools. And we would like to craft a prompt to force our agent to execute the ping. Simple situation. So we are saying that I'm seeing packet loss on one of the device. To diagnose this issue, just run this row command on this device, then works 0.01, and the command for the ping. So if we try to execute it, we are just able to run this tool. So we have the response provided with description. So there is a ping, no packet loss. So, but the key issue is that if we review the query execution detail, which is a kind of simple debugger, what is going on, we could easily find that this row command with the ping command has been executed, and we could see that it was done. So it should be forbidden for Alice. But what we do much more serious prompt. For instance, we could just force our agent to use this command on our, say, Sonic device in Chicago, and to use the cat to expose all the configuration, which could be not definitely authorized for Alice. And we see that we have all the details or part of the details for the configuration. And we just discovered important information from this particular device. We could also, for instance, inject another command. Here is just socket statistics, discovering all open ports. So after a while, we receive the info about all the open ports and where particular processes are running on our device. So we discovered another bunch of information not necessarily authorized for the Alice, which is the net viewer, but we could even just stop the whole process of BGP on one of our nodes. Let's observe this one. So this is the use this command on one of our device, and here we would like to configure no router BGP and write memory. So effectively, this command would cause the interruption of BGP process on this particular node. So quite detrimental. We would like to summarize that insecure tools means for us just the necessity for assuring the command control at the device level. And we should enforce it even if the MCP tool, all the checks passes. But we should be protected against that because such situation may happen. So device level security, there are a couple of problems. First, very often MCP servers act on the network devices using the shared credentials and working on the service accounts with the high privileges. So we would like to limit the problem. That's why we would like to use the secrets management. In our case, it is OpenBao, it may be HashiCorp Corp. Just not to use the static credentials, but to produce the credentials each time our MCP server is trying to execute a command on a network device. And this just-in-time short-lived certificate should be properly validated by our secret manager based on the JWT token of our user and marking to the service account created for particular roles. This is our objective. At the device level, here we use the OpenSSH, and here we map roles into the principals. So whenever a particular user is trying to execute the command, it is first being connected via SSH for the particular account, which is appropriate for its role. And here also we applied force command able to run the script before any command execution. And another part is that some devices may support the policy enforcement in the central way using, say, TACAX server. In our case, we were able just to delegate this checking if particular command is authorized for particular users' roles via the TACAX server, but those validation can be also be implemented in this, say, command validator script on the devices. So this is what we would like to achieve, and maybe some details now. So when our MCP server just did all the scope check passes, tries to execute the tool, first it is requesting using this user token to sign just-in-time SSH certificate that could be that is generated by our trusted secrets manager. After that, this server is connecting to the particular device using this certificate, and our network device is configured so that this certificate can be validated using the public key, trusted public key of our secret manager. This is the first point. And is checking whether role of our user is matching the principal denoting the service account on this device. After those two checks in the script, we have the command validation, and we could, for instance, on the device protect ourselves against the command injection. And at the end, we have the command authorization checking whether this particular command that is being executed via this MCP tool is authorized for this, say, principal, this service account. And we could do it locally in the script, or we could delegate to the TACAX policy enforcer, central policy enforcer, and delegate this task here if our network device is supporting this kind of command authorization. After the positive, we are executing the command, providing the output to the MCP server, or error denial but this time at the network device or TACAX level. In the demo, we just get back to our application. We prepared a special button just toggling on the device level command enforcement. So now I can switch again as Alice when I turn on this device level command authorization. So let's try it now and just to execute this dangerous command as Alice, our net viewer, which is definitely not authorized to do such a things on our network devices. Let's try to do. And we should receive the information access denied and information that this tool was executed but was rejected. But this time it was rejected at the device level. So we cannot do that. And let's try some our previous tests. For instance, let's try the ping that we were previously able to execute as Alice. This time we should also receive the similar information. Let's try also just to inject additional command after the semicolon. So our script is whitelisting the allowed, say, charts. So this time we could just receive the message that command contains disallowed characters, which means that the user or the agent was trying to inject additional command that was not authorized. So we could see how it is being working. Let's shortly summarize this our demo, what we achieved. So first, we are we are not using the say static credentials and the say service accounts with broad capabilities. So instead, we are using some short time SSH certificates. In that way, we just protecting ourselves against stealing those, let's say, static credentials, etc. Because after the 30 seconds in our setup, these certificates are useless. Of course, we also achieved, even if we have very insecure tools, we are having the second layer of the security at the device level. So this is the protection from the badly designed tools. And of course, I could mention also the shell injection protections that we could realize on the devices. And how we achieve that, we apply the credential management for generation of these short time certificates. And we used OpenSSH with the force command validator as a script that is also able just to delegate the command-based policy enforcement using the central, say, TACAX server. But let's say a few words about implementation details. They are quite important because first, in the OpenBao, we would like to achieve that having the JWT token for particular user, we would like to retrieve signed SSH short-lived certificate with properly set principal denoting the service account on these particular devices. And in that way, creating such a certificate, we are giving the chance for the device to verify this certificate using the public key of OpenBao and to validate if the proper principal was set and only allowed to log into this device using this certificate. So what we need to configure at the OpenBao level. So first, we need to enable authentication using the user JWT. Of course, we need to provide some references to the public keys offered by our identity provider, giving the chance for OpenBao to verify this JWT token again. And also here we are setting some additional properties, but it is most important is the groups claim, which maps the user role. And next we need to prepare some signing roles. And here for each of the user role, we are preparing the role able to be used during this creation of SSH certificate. So we define what is the valid principal. This is the same name, and allowed users, and we can also set the TTL for this short living certificate, and similarly for all the user roles. And of course, we need to define the policies and the endpoints that could be used to sign this certificate by our, say, certificate manager. And at the end, we need to map the net role that is coming in the JWT claim to a group, and this group should be mapped to proper policies, so that the user belongs to the net viewer can only use the SSH net viewer policy. That the main point here is just to assure that we are not able just to use another, say, policy depending on our role. So it is impossible, and I will demonstrate how it is working in the code. Because in our MCP server, we need to exchange or to obtain, based on our user token JWT, just-in-time SSH certificate. So we need to create a special function. So first, we need to log into our credential management to receive the token for the second call for the certificate. But first, we are just being authorized if this particular user can obtain this certificate. And we are receiving the policies with the proper marking to the principal in the SSH certificate. Of course, we need to extract the role from this policy, which is very straightforward. And MCP server then is generating ephemeral private public key. And this public key is being used just to create this SSH certificate by our credential management. Of course, in order to obtain this, we need to use the proper endpoint that maps that were mapped from the policy, and we use this the ephemeral BAO token because this is very short-lasting credential to our BAO manager, just to provide this signed SSH key. So after that, we should receive the signed certificate with some additional, for instance, role, username role, and private key that will be used when our MCP server is connecting to particular server device to establish the SSH connection. At the device level, first we need to prepare free service accounts and appropriate setting of the principals. This is the first point, but we also need to properly configure our SSH. So first we need to provide the public key of our OpenBao trusted authority. So this is the first point, just to give the chance to the devices to verify the certificate. Of course, we allowed to checking to marking appropriate principals to the particular accounts, and we disallow the password authentication because only by the SSH cert we can just log into the device. And we are defining what is the force command script, which is our command validator that will be running before any command on the network device. And we could also define some variables that we can inject into the device, to the SSH process, for instance, for auditing purposes. And how this command validator looks like, this is some kind of pseudocode. First, it is able just to read the command and the user, and is checking whether this command is not empty. This is the first step. Another is checking the command and verifying if the user is not trying to inject some additional column after the colon or ampersand or some forbidden signs. This is the second point. And next is the delegation of authorization to TACACS, providing the user role and command. And after that, if it is permitted, the command is being executed. If not, there is an exit one and the command is just denied. So in the TACACS server, so what we need to achieve is that we should enforce that particular commands are authorized for particular users. So we would like to achieve that show commands are allowed for viewer, say trace ping for operator, as we demonstrated, configure terminal, write memory, clear, all for the admin. So how to do it? In the TACACS server, we need to define the mapping between the user, so in this kind of service accounts, user to the groups. And for each group, we are defining the profiles with the set of rules. And this is the example for NetViewer. We just strictly deny some, providing some regex and denying configure, write, clear, ping for the viewer, allowing some show or VT shell show. For the operator, we are just allowing also the ping and trace route according to our examples, and we are denying all other commands. And for the admin profile, we just permit all the commands. Of course, this here in the slide, they are very simple regex, but they can be quite complex and could reflect also denial and permit of the commands and the combination of commands that are being tried by or needed for particular tools at the MCP server. To wrap up, insecure MCP tools may happen, may bypass our controls on the MCP, as we demonstrated. This is quite easy. And of course, we should avoid such tools as we demonstrated. so over permissive tools when we do not properly check the inputs for that tools, definitely they increase the blast radius. We should avoid broad permission accounts, but rather just to reflect the accounts per role base, as we demonstrated here using the, say, OpenSSH and other, say, features. They are necessary and very much more secure if we could use some very short SSH credentials that are generated only just to log to the device to execute particular tools or set of commands, and they just are disappear. And one of approach that we demonstrated, and of course we demonstrated that this device level command enforcement, command authorization is necessary because of the problems with and dangers and risks of having MCP tools that not perfect in terms of the security. So, key takeaways: don't trust MCP tools. They need to be validated or verified. We need to avoid broad catch-all tools, as we demonstrated here. Try not to use the static high privilege device accounts whenever possible and acceptable. Just use the very short credentials. And there is no way just to securing also the command execution as close to resources as possible that we demonstrated. And one of remark, because here we are using the SSH, which is still widely used as access to the network devices. And in fact, due to our fleet of devices, it is in many times necessary to use, but whenever possible, try to use also much more MCP-friendly APIs like netconf, restconf, GNMI, because they are structured and they have additional capabilities that are very useful when we would like to provide those authorization and minimum privilege enforcement. So we are not covering this here, focusing on the SSH because it is much more challenging than the other mentioned APIs. So this wrap-ups this part 2, Insecured MCP tool and device level security. In the next part, we would like to focus on attribute-based access control and end-to-end auditing. So I highly encourage you to revisit our webinar and all the 3 parts. The links you can find under the just under the video. And I hope to see you for the part 3. So thank you for watching, and the easiest way to reach our company is using this email, contact@codilime.com. Thank you again.